the question is, f is a continuous function from R to R that takes the values in Z or in Q, then so that f is constant function. Okay, so given that f is a continuous function first, and if the function taking values in Z, integer or rational, then we have to prove that f is a constant function. Okay, let us prove this. So we prove this by contradiction method. Okay, so firstly we assume that if possible, let f is not a constant function. So f is not a constant function, that means f is a non-constant function. So then there exist 2 points x1 and x2 belongs to R, such that the image of x1 and x2 not equal, or you can say that the image of x1 and x2 are different. Why? Because f is the non-constant function. And also see here that if taking values in Z or in Q, so we assume that if taking values in Q, uh, assume that f of x1 comma f of x2 belongs to Q. Because why? Because this is given the function f taking values in Z or in Q. We assume that the function f taking values from Q, rational number. And also we see here that f of x1 not equal to f of x2. Why? Because the function is a non-constant function. Okay. Now we apply here the density property of R. Okay, by density property of R, what we can say? By density property of R, we can say that there exists an irrational number say Q. Okay, by density property of R, we can say that there exists an irrational number say Q in between f of x1 and f of x2. So by the density property, what density property says? Density property says that there is a irrational number between any two rational number, and also there is an rational number between any two irrational number. So since f of x1 and f of x2 belongs to Q, then in between these 2 points there is a irrational number Q. Okay, now since f is continuous on R, then f is also continuous on closed interval x1 comma x2, or you can say that closed interval x2 comma x1. Why? Because we don't know who is bigger, x1 or x2. So we can say that f is also continuous on x1 comma x2 or x2 comma x1. Okay, now we apply here the intermediate value theorem. apply here IVT. So see here the function is continuous, and we and here f of x1 not equal to f of x2, then we can eligible for applying IVT property. So by IVT property we can say that there exists an element C belongs to x1 comma x2 open interval x1 comma x2, or C belongs to x2 comma x1 such that f of C that equal to q, that equal to q. Okay, now see here, that is our contradiction. How? Just a second, just a second. See, we see here f of x1 and f of x2 both are belongs to q, and also we assume that the function f taking values from q rational number, and see here carefully that we take a rational irrational number q in between x1 and x2, and then we apply the IVT theorem on the interval x1 x2 or x2 x1 whatever. uh, by applying IVT we can say that there exists an element C in between x1 x2, or you can say open interval x2 x1 such that f of C that equal to q. Why? Because we know by IVT theorem that if assume all the value in between f of x1 and f of x2, and see uh, q is also a member in between f of x1 and f of x2, then by the statement of IVT theorem we can say that if also assume q, then we can say that f of C equal to q. But see here, this is a contradiction. How? So we know that this is a rational number, because if taking the values from q, and this is a irrational number, so rational number is not equal to irrational number, but we see here that uh, rational number equal to irrational number, which is not possible, or you can say that this is a contradiction. So so our assumption is wrong. What we assume? We assume that f is not a constant function, that is f is a non-constant function, but our assumption is wrong. So what is true? F is a constant function. Hence proved.